Alrighty. So today what we're doing is we're solving rational inequalities, okay? And we're going to follow a similar process as we've followed for quadratics and square roots and all that good stuff. We're going to find our critical values, we're going to put them on a number line, and we're going to test points to figure out which values make the inequality true, okay? So we're going to start with a simple one. 8 over x plus 5 is less than or equal to 4. Okay. What we're going to do first is we're going to rewrite this as an equation. So 8 over x plus 5 equals 4. Okay? Now, in order to solve this equation, this is a really simple one, so if you want to think about cross-multiplying, I understand. But remember our process. Our process is to get a common denominator. What would our common denominator be? X plus 5. Do we need to do anything to the 8? No. No. So we have 8 equals, what do we need to do to the 4? All right, so everyone okay with that? All right, then we would distribute that 4, so we would have 8 equals 4x plus 20. Subtract your 20, so you have negative 12 equals 4x, and x equals negative 3. Everyone okay with that? Okay, so that's one of what we're going to call our critical values, okay? Your other critical value is going to come from any x values that would make your function undefined. So what are any x values that would make this equation undefined? Okay. So these two values, x equals negative 5 and x equals 3, those two values are called your critical values. And the critical values are the numbers that you are going to place on your number line. Make sure you put them in the correct order. All right. Negative 5. Is there going to be an open circle or a closed circle at negative 5?
Open.
Open. Why? Yeah, this is an undefined x value, right? The function does not exist at negative 5, so the solution to the inequality can't exist at negative 5. X cannot equal negative 5. Okay, what about negative 3? Closed. Why? Yeah, this sign says less than or equal to. Well, x equals negative 3 is what makes this equal to 4. What if this was just less than? Then it would be open. Okay? From here, you're going to test points in every section. Do you see how we've created 3 sections of the number line? So now we test points in each section. Okay? Sometimes when you deal with rational functions, it's easier to test extreme numbers, like 100, 1,000, 10,000. Because you don't really care what the value is, you just care, is it bigger than the number or less than the number? That process doesn't always work, but sometimes it makes your life a little easier. So I just want to throw it out there to you. So let's try and see what that looks like. What if we try negative 100? Okay? So we think of 8 over some big negative number, right? In this case, it's negative 95. Is that going to be less than 4? Yeah, because that's going to be a negative fraction, right? Which is less than 4. So this is a true part of the number line, which means we shade. All right, what can we test between negative 5 and negative 3? Let's practice those number line skills. Negative 4. Everyone okay? All right. So 8 over negative 4 plus 5 is 1. Is that less than or equal to 4? No. So that part of the number line is false. All right, let's try a big number. Let's try 100. 8 over 100 or 105 or 1,005 is going to be a little bitty fraction, right? 8 over some big number. Is 8 over some big number going to be less than 4? Yes. So again, this section is true, so we shade.
So is it like, if it's on the left side, can it be in the middle?
Yeah. So it's not always going to alternate yes, no, yes, no. It's not going to always do that. You do need to check all the sections. It could be one section, could be 2 sections in a row. There's lots that could be going on. Okay?
All of it too.
It'd be a really weird case, but yeah, technically it could. All right, so let's go ahead and turn this into our answer. And to do that, we write it as an interval. So this is negative infinity to negative 5 with a parentheses, union 3 to infinity. Sorry, negative 3 to infinity. Okay, I enjoy having steps, so let's recount the steps to solve this problem. What did we do first? Even before we got a common denominator. Not equal to 0, we wrote it as an equation. Good. So that was up here, step 1. Step 2, we went ahead and solved that equation. Yes, by getting an LCD. Then what did we do? Okay, we had to find the other one, and how did we find it? Good. Find x values, or find undefined x values. And steps 2 and 3 are finding our what? Critical values. Okay. Step 4. Put on the number line. Good. Yep, and step 5 was to test each section to get your solution.
Could you have just one number? Will there ever be multiple, like, x can equal 5, x can equal 4,
Mm-hmm.
so you have to test, like, each?
Mm-hmm.
But you can just have one.
Hmm?
You can just have, like, one.
What do you mean, one of them?
Like, one value.
I guess potentially you could just have one critical value, but we'll probably have 2 and more.
So if there's more than one undefined x values, are you
Mm-hmm. And we'll see an example of that in just a second. All right, everyone have the steps that wants them? All right, so we start off by rewriting this as an equation. Okay, what's our common denominator? Y. So we need to take y plus 5 and multiply it by what? Is everyone okay that I'm not writing it over the LCD? You know that that's implied, right?
Yeah.
Okay, then we set our numerators equal. All right, distribute your y. So we'd have y squared plus 5y equals 6. We have to set it equal to 0 now. So y squared plus 5y minus 6 equals 0. How do we solve this quadratic? Factor it. Y plus 6, y minus 1. All right, so our two solutions are okay. And then what do we do? Yeah, the other critical value comes from our original equation. What can y not equal? 0. So those are our critical values now. So we're going to plot that on a number line. Again, make sure you go in order. Oh, right, you're right. -6. Thanks. All right. What kind of circle is at -6? Closed. Why? Yep, greater than or equal to. What kind of point is at 0? Open, because that's an undefined x value. And what about at 1? All right, how many regions do you have to test this time? 4. Less than 6, between -6 and 0, between 0 and 1, and greater than 1. Will you please test your values and figure out which ones work? Don't try and do it all in your head. Write it out if you need to. All right, what about less than 6? -6. Does it work? Yes, it does. Think about plugging in a really big negative. If you plug in -100, you'd have -95. Is that less than 6 over -100? Yeah. This is a little fraction. This is a big negative. Okay, what about between -6 and 0? Nope. 0 to 1? And 1 to infinity? Is it always going to alternate like that? No. Make sure you rewrite your answer as an interval. Yes.
Can you go over just one more time how you find the bottom of the denominator and like -5 is less than 600? Explain how you found like in the 6 over -180 how you found the -180.
This is -100.
Oh.
Other questions? All right, let's try number 3. All right, so we start by rewriting this as an equation. What is our LCD? What's missing from the first fraction? So we're going to multiply the numerator by x minus 6. What's missing from the next fraction? We take x minus 4 times x. All right, go ahead and double distribute. We would get x squared minus 8x plus 12 equals x squared minus 4x. What happens with the x squareds on both sides? They cancel, so we get negative 8x plus 12 equals negative 4x. So 12 equals 4x, and what does x equal?
Negative 3.
Should be a positive 3. All right, what are our undefined x values? X can equal 0, and x can equal 6. All right, we take those guys, and that's what goes on our number line. What kind of circle at 0?
Open.
At 3?
Open.
And at 6?
Open.
Questions on any of those, open versus closed? All right. These two rows, why don't y'all test the number less than 0? Okay. Y'all test the number between 3 and 6, or sorry, between 0 and 3. Y'all test the number between 3 and 6. And y'all test the number greater than 6. All right, do numbers less than 0 work? Less than 0? No. Between 0 and 3?
Yes.
Between 3 and 6?
No.
And between 6 and infinity?
Yes.
Will they always alternate?
No.
I'm going to keep saying that until you so that you make sure you follow that. I don't want you falling into that trap. Anyone need help figuring out any of these sections? Okay, so I turn this into 0 to 3, union 6 to infinity. Questions on that? All right. I'm skipping my number 4. You are welcome to write this as a number 4, but this one I want you to try on your own. X plus 1 over x minus 5 is less than or equal to 0. Try this one on your own. Okay.
You solve your three minus equals three.
Yeah.
Your undefined value is x minus 5. You look like you should be there. Plus 5. Oh, no. Right. The other thing is solve. Cross space.
What did you use for those?
All right, so you solved this equation and you got x equals what? -1. What was your undefined x value? X can equal 5. You plotted these. Okay. What kind of circle at -1? All right, what about at 5? Okay. Did values less than -1 work?
No.
What about values between -1 and 5?
Yeah.
Values greater than 5?
No.
Anyone not sure and need me to test one of those points with them?
Yeah.
Which one?
Less than -1.
Less than -1? Okay. That's okay. Let's let's try negative. What did you try? What do you want to try? -2. So -2 plus 1 is -1 over -2 minus 5 is -7. I don't know if that's less than or equal to 0. Negative over negative becomes positive 1/7 is not less than 0. Okay. To talk about why circles are open or closed. At -1, this is closed because of this sign right here. Once less than or equal to. Well, this is equal to -1. -1's where they intersect. So that one is closed. Your undefined values will always be open. Because the function does not exist at that x value. Okay? So how would you write your final answer? Good. All right, let's look at number 6. All right, so we start by rewriting this as an equation. What's our LCD? Okay. What's missing from our first fraction? So this becomes 3 times x minus 2. And what's missing from our next fraction? Good. All right, are any of you tempted to cancel these 3's?
Yeah.
Okay. You are allowed to cancel the 3's because it's a 3. It's a value. And that is never going to equal a root. Okay? However, if those were x's, you cannot cancel variables like that. You never want to divide by variables that will cancel because you risk losing a solution. So I never want you to divide by a variable. But if you want to cancel out a number, if you want to cross put the numbers out, you may.
So it's okay if it's a number in front of it.
But not if it's a variable. Okay? So this would give us x minus 2 equals x plus 3. Sorry, was there another question?
Oh, no, just kidding.
Okay. What happens here? The x's, when we move everything over, the x's cancel and we get negative 2 equals 3. Does negative 2 equal 3? No. So this equation has no solution. That does not mean that the inequality has no solution. Okay? All that means is that you do not get any critical values from your equation. Callie?
Do you have to cross out the variable at the beginning?
No, you don't have to. If you distribute, you're still going to get no solution. Okay? You still have to go, once you find this no solution, though, you still have to go get your critical values from up here. What are they? Negative 3 and 2. So you just go through your process using negative 3 and 2. You just don't gain any extra critical values from solving the equation. Does that make sense? When you reach no solution, you can't stop. It's no solution to the equation, not to the inequality. Okay? So then you do need to go ahead and test values. What are our circles at negative 3 and 2? Open. All right, let's try negative 4. If I plug in 3 over negative 4 plus 3 is negative 1. I want to know if that's greater than 3 over negative 6. Is negative 3 greater than negative 1/2? No. All right, what do you want to test between negative 3 and 2? 0. So I try 3 over 3. Is that greater than 3 over negative 2?
Yes.
Yes. And I test a number bigger than 2. Let's try 3. So that gives me 3 over 6. Is that greater than 3 over 1?
No.
No. Are they always going to alternate?
No.
No. Jason. Oh, okay.
Well, I had a question now,
Questions on that one? All right.